Hi. So in this video, we will understand how uh, on-prem schema registry works. That helps in schema evolution in Kafka. Okay. So we store schema registry that acts like a repository where we keep the schema. Okay, and any schema gets updated, gets changed. Okay, so that change can be made available, can be registered in this on-prem schema registry, so that the consumers, okay, or the producers can access that updated schema, the schema registry. Okay, so it's a so that is it's a place where you can keep your schema, update the schema. Okay, and both producer and consumer can access that updated schema. So this is how schema evolution works in Kafka. We'll understand from this given code. Okay, so here is this is the code for a producer. She's producing she's providing the data. Okay, topic where score the incoming records, and then from the topic those records are being consumed by the consumer. Okay, so this is a producer which produces the data. Okay, so here what I've done. Okay. So here in this code, I have a separate schemas. Okay, schema one. So this is the existing schema type, name, namespace, and these are the fields: name, user ID, page, action, timestamp, and the type of that. This is the schema. So in producer one, I'm opening the schema step one underscore schema.json. So this schema gets loaded. Okay. And the schema, if you observe, nothing but it's like dictionary, key and the value. Okay. It's in JSON format. And the if you look at the records, they are of type dictionary. Okay. So here I'm opening the schema. Okay. So schema, as I mentioned in the what can say comment, that it's a blueprint. Okay. So this is how the data should look for this is or the format of the data sheet. Okay. So I'm loading that into the loading the JSON file into a variable called schema dict. Okay. Then the fast arrow dot parse schema. What it does, it validates the schema. The purpose to use fast arrow. Yeah. So what fast arrow does? The fast arrow is used to validate. It's an highly optimized Python library. Okay. For working with Apache Agro data. So what it does, it's a built-in parse fast agro is used for validation of the schema. And it is significantly faster. That's the reason we use it over here. Okay, to validate the schema. Right. And then we have parse schema function, built-in function. What it does, it takes the raw Python dictionary, okay, that representing agro schema, prepare it for engine execution. So it prepare it for execution. So it is parsing it. Okay. And then we have this schema dictionary variable where we have loaded the scheme. So it is going to validate that schema which we have declared. Okay, once that is validated, it's get loaded, okay, into the objects called schema. So we have several schemas in our project folder. Selected one of the schema, okay, and I have loaded into the variable. Now, once we have parsed it to a fast arrow, what we are going to do? We are going to register the schema. Register schema with the schema register. Okay, so this is the location where the consumer and producer are going to look for the schema. So they can access the schema at this schema register. Okay, so what it is? Schema registry is a server that stores schema centrally, as I mentioned. When we register, it gives back a unique ID. Now, whenever we register a schema, use a unique ID number for our schema. So that's how we identify it. Okay. So in a registry, there can be several schema loaded into the registry. So how you are going to identify them? You are going to identify them with a unique ID number. So the register, what it does, gives a unique ID number to our schema. Okay. The consumer will also use this ID to know how to decode our message. So whenever consumer is consuming the message, okay, and it wants to validate the data as per the schema, it's unique ID. And accordingly that it is going to decode the data. So here we are requesting, so this is where we are going to, this is the code. We are going to register the schema. Okay. So what it is, basically it's an HTTP post request to the schema server, create a register resource. Okay, so what it is saying, it is an request to this, okay, sent as an HTTP post, the schema registry to create a register or create a register resource for the schema. Okay, and then the target URL. What is the target URL? Okay, so this is the target URL: schema registry subjects, topic, value, and versions. Okay, so what it is actually? So this is a standard schema registry API structure. This is the standard schema API structure. Okay, and here the topic is nothing but a topic which we have over here. Topic is clickstream. Okay, so that goes here into the topic, and value. So the name of this here, the name of the name becomes clickstream hyphen value. Okay, this is how it becomes. This is how it is named. Okay, the topic name and the value. Okay, this is how the naming strategy is. So it's a strategy of how you are naming the, okay, and then the versions. Okay, so it will be version 1, version 2, version 3, like that. Schema subjects, then the underscore topic. Fine. The name of the topic is whatever topic you have with you. Then the value, then is the naming strategy and the versions. Okay, so every schema, so when you register new version or new schema, accordingly it will take the new version. So version 1, version 2, version 3, like that. Okay, so content type application, and here dot schema registry dot 1 dot v1. Dot v1 indicates that it's a version 1 plus JSON file, right? So it is a format of JSON, and it's v1 indicates it's a version 1. Okay, then here we have created the resource, or the registered the resource for our schema, and what we are going to, we are whatever schema we have in schema underscore dictionary, we are putting it schema. Okay, whatever it is. So schema dictionary, it is a JSON file. So we are converting it into a serialized Python s- structure. Okay, so that it can be sent over a network. Okay, right. So that's how the things are. Only to send over a network, we are converting the schema dictionary into a serialized format. Okay, and that can be sent over and over. So this is how we generate the request and we get the response. Okay, and here what once the schema is registered, we get the ID. Okay, what we can extract the ID. So when the schema get registered, schema registry. Okay, so what will generate an ID and we can extract that ID. So from here, this correspond or dash JSON ID will get the ID of the schema. Schema registered. So here I am printing a message, schema registered with schema registered, got ID, whatever is the ID, got that. So it is the first schema, but naturally the ID will be one. Okay. Here the Kafka producer create the Kafka producer. The producer is the thing that sends the message. So here we are bootstrapping, we are launching the Kafka broker sir, for the producer. Okay. Then we are creating the events. So home, these are pages, web pages like home, product, part, checkout. And these are actions by the user, click, view, and scroll, something like that. So we are creating 5 random events based on the format of our schema, user ID, page action, timestamp. Then we are going to do, once the producer has produced the data according to the schema, we are going to encode the event using constant wire for now. So we have to send that event across network to the particular topic which we have where it will be stored so that the consumers can consume it. So send the data in this format byte 0. So this byte 0 initial signals that it's an Avro data, Avro formatted data. Then byte 1 to 4 is nothing but the schema ID to indicate which schema you're going to use. And from byte 5 onwards, you have the actual data. This data. So everything is sent as a byte into format of bytes. So it's a stream of events. It's a byte, so format into byte. Okay. So you can see we have used buff equal to bytes IO input output. So what is bytes input output? So whatever data we have, we are converting it into byte of streams. Okay. So that's the reason we use buff over here. Okay. So it says binary stream. Basically, why we use it? Bytes input output. It creates an in-memory binary stream so that the data can be sent over a network. So here we have bytes. We are initiating this. We are writing the magic bytes. Magic byte is nothing but indicating that it's an Avro formatted data. Then here 4 bytes of schema ID. So whatever schema you have registered, that will come over here, converting it to bytes. Then you are sending fast Avro.schemaless writer. So why we are saying it schemaless? Okay. So we are just sending a blueprint of the schema. Okay. So we have the event, we have this data, the schema which we have registered, and this buff initiated to send it as binary stream of data. So here what exactly happens? We are not directly sending the schema, but the blueprint of the schema. So it's a raw, pure binary bytes without including the schema definition inside the payload. Okay, so we have just sending the blueprint of the schema, not the schema definition. You are not including schema definition inside the payload, but just the blueprint. Okay, why it is sent as why it is different and why we call it schemaless? Because every single message is sent to a streaming platform like Kafka would create massive overhead. To so if you are sending a message to, uh, to a streaming platform like a Kafka, may create a massive overhead. Okay, so for example, let's say you have a schema for 2000 bytes and your message payload is only 5 bytes. So what happened? We waste huge amount of network bandwidth only sending the schema of 2000 bytes. That is the schema writer solve this by stripping the schema away. So it doesn't send the schema. What it does, it uses schema object strictly as a blueprint, convert the event highly compact binary bytes. So what it is doing, schema just as a blueprint for the data to be sent as highly compacted binary bytes. So the schema doesn't go along with that. It sends the data in the format of the schema so that it can reduce the bandwidth of sending huge amount of data. So every time when I send a message, uh, I have to send the schema also. So what it schema also. So what happens? The bandwidth increases. So instead of sending the schema every time, I just send the blueprint of the schema so that I format the data according to the format of the schema, sent to highly compacted binary bytes. So I don't have to send the schema every now and then. But yes, it follows the pattern of the schema which is being registered in the schema registry. Okay. So if you have registered a certain schema inside the schema registry, it will follow that pattern, that format of schema. And accordingly, it will use it as a blueprint to send the data. Okay. The topping. Fine. So this is how the thing happens. Then it sends the data. It gets the value from the buffer, VUF input output bytes, and the topic where you want to send it, and it flushes out the data. This is how it the schema gets registered. Okay, independent schemas are created in a schema folder that are being loaded into this schema registry. It is given a name according to the topic. Okay, which the data is intended. That topic name is given. Okay, you register versions of the schema, version 1, version 2, version 3. Then you extract the what we can see dictionary. Okay, you serialize the Python format of the dictionary, sent sent over a network. Then you extract to find out what is the ID. You can use this code to find the ID of the schema. Okay, then you create the producer. Okay, then you create the events, pattern of events you want. Then with the help this do the exact data you want to cut. Then you attach certain things along with the data. You attach the magic byte, that is it's an arrow formatted, the indicate that is an arrow formatted data, the schema. Okay, then the actual data. Then what you do after once you do that, send the data as a schema less writer, sending the data, the blueprint of the schema which is being stored in the register. So that's how it happens. So even let's say if I do it, so let's say if step consumer, go in the consumer, what it is going to do, the consumer is going to extract the schema. Okay, we cache the schema, so we don't ask the schema registry or on every single message. So what you are going to do, it is going to cache the schema which is there in the schema registry. So you can check. Okay. So here it is this registry from where they are going to extract the schema ID. So you get the request the URL, you get the response for that schema ID. Okay. So you fast tableau.par schema, draw whatever is the schema that is going to being extracted. Okay. Then you will get the schema ID. Okay. Once the schema ID is known, then accordingly, the consumer will get whatever data it is getting from the topic which is being sent by the producer. Okay. So it will match the schema. If we match the schema ID, okay, fine, with whatever data is arriving from the top. Because when we have sent the data from the producer, we have sent the data, then the schema ID, for what schema ID the data is registered, that schema, and then the, or what we can say, agro formatted bytecode. Okay, so that will help the consumer to understand that, okay, the data is arriving formatted for this particular schema ID. The data arriving data is based on the blueprint of this registered schema ID, which we have extracted from the, what we can say, schema register, and it's matching with that particular format. Okay. So once schema ID from both the ends are matched, consumer level also and producer level. Okay. So the data is being by the consumer. So you can see. So here a consumer is consuming and it is listing a topic. Okay. So here everything happens. Here it gets the schema ID. So once the schema ID matches and it is same, then it starts taking the data from the topic exactly as sent by the producer. Okay. So this is just I wanted to tell in this video that how my registry takes place, how both producer and consumer utilize that schema ID, match this data as per the schema, for as per the format of the schema, as per the print of the schema, and accordingly, uh, communication of the data or flow of the data takes place from the producer topic and from topic consumer. Thank you very much.